Hello, Year 8. Today we're going to carry on our work with constructions and we're going to do something called loci. So we're going to use the construction skills that we developed in the previous lesson on bisecting lines and on bisecting angles and use those in more challenging scenarios. So a locus or a loci, if you've just got one, is a line or a curve determined by a rule. And some of the rules that we're going to be using today will produce some straight lines. Some of the rules that we use today might produce circles or parts of circles. And we're also going to have some scenarios that lead to our line bisectors and angle bisectors that we constructed last lesson. Now, although we know what a line bisector looks like and what an angle bisector looks like, you might hear some slightly different language today that I'm just going to explain. So for example, with a line bisector, I'm also going to refer to this as a equal distance from 2 points, and I'll explain what that means in a moment, but you might also see this word equidistant, which basically means equal distance. So in a line bisector, this red line, if I take any point on this line, say I call that C, that is an equal distance between A, and it is also an equal distance between B, and it wouldn't matter whatever point I picked on that line, it would be an equal distance between A and B. So if you see in some of the questions later on that we try, it talking about a pathway or a locus that is an equal distance between 2 points, we are going to be constructing a line bisector. Similarly, we have something called the angle bisector, and that is actually equidistant between two connecting lines. And what I mean by that is here is a picture of our angle bisector, and this red line represents that bisector. If I pick any point on here and was to measure that perpendicular distance from the line A and also from line B, those distances would be exactly the same. Doesn't matter which point I pick, the distance between the lines is identical. And that is going to be important in the example we look at now. So in my example, we are going to have to think about really carefully what sort of constructions we might need. Okay, and we'll try and describe each of them as a bullet point, and then we'll look about how we're going to construct each. So example, what might we need to draw to satisfy each of these instructions? Describe them in words, use the 3 bullet points. So we'll read this thing through and then we'll have a little bit of a think. It says David wants to plant a tree in his garden. It needs to be closer to the wall than the house. It also needs to be at least 20 meters away from corner C. And David would also prefer if the tree was nearer point B than point A, and we're going to show the area that he could plant his tree. Well, let's take each of these instructions in turn and try and break it down. First of all, it says it needs to be closer to the wall than the house. So it's got to be closer to this line than this line. Okay? Now we know that an angle bisector is exactly the middle of these two lines. So if we draw an angle bisector in, we then need one side of that line. So this first section here, we're going to need an angle bisector at C. And I will explain all of these again as we actually construct it on the diagram. Okay, it needs to be at least 20 meters away from corner C. So it's got to be beyond a point that is 20 meters away from C. And that's going to be a part of a circle. So we're going to be constructing a circle with radius 20 meters. We'll have to think about the scale in a minute. So part of a circle, radius 20 meters. And finally, it needs to be nearer B than A. That's kind of similar to the first thing. If it's going to be nearer A than B, nearer B than A, we're going to need a line bisector, and it's going to be one side of that line. Because remember, a line bisector, all the points are the equal distance, and we want it to be closer to B. So we're going to need a line bisector of A, B. So let's have a look how we might draw these things, construct these things using the diagram given. So, interpreting that it needs to be closer to the wall than the house. So we are closer to this line than this line. We are going to be drawing an angle bisector, and then it will be this side of the angle bisector that is closer to the wall. Remember, all the points along the bisector would be the exact same distance. So I'm going to use my angle bisecting technique from last lesson. I'm going to create an arc at point C. I'm going to move my compass point to where these intersect. So I'm not drawing any of this, just freehand. Every single line is going to be constructed. So remember, where these intersect, I'm going to be joining back to C, and that is going to be my angle bisector. So using my ruler, I draw my angle bisector now in. So for my second construction, I am trying to do all the points that are at least 20 meters away from corner C. So anything using the scale that is 2 centimeters away from C. So it could be 2 centimeters in that direction, 2 centimeters in that direction, 2 centimeters literally in any direction. So the way that I need to do this one is I need to set my compasses to 2 centimeters, because that would be 20 meters. I need to put my compass point on C and create an arc that crosses from the wall to the house. So that inner circle, remember this one was for my first construction, that inner circle is all the points that are 2 centimeters away from C, or 20 meters using the scale. So the tree needs to be beyond that arc. Finally, for our third construction, it says David would prefer if the tree was nearer point B, than point A. Okay, and this is our line bisector. Okay, if we have a line between A and B in the middle, they would be all the points that are the exact same distance. So if it's that side of the line, it would be closer to B. So remember, for a line bisector, we're just opening up our compasses to a little bit more than half. Okay, and it's an arc above and below the line. If you can't see where mine crosses below the line, I will move it up in a moment so we can see. And then same distance from point A. And I'm looking for where my two arcs cross, and we can just see that without me adjusting. Got this point here and this point here. So using my ruler, that is my line bisector. So where could the tree be? Well, this was our first one, and it had to be closer to the wall, so that side of the line. Okay, remember this inner curve was our second one, and it needed to be further away than that corner, so beyond that curve. And it also needed to be nearer to B, so this side of the line. So the boundaries are kind of here, along this line here, and along this part of the curve. So where could the tree be? It could be anywhere in this shaded region, which I will call R. So finally, year 8, all of the questions, there's 4 of them that I'd like you to do, are on the PowerPoint. You can have a look at those questions. I have provided an answer sheet if you can print it out. If you can't print it out, you will have to draw the initial diagrams to begin with. So I'll leave that entirely up to you as to what is easiest. Please read through the rest of the instructions, and remember, you can always contact me on Ask the Teacher if you've got any problems.